Hi, I'm Sean with Create Your Lifestyle Academy, and you are watching Beyond the Bonds, Episode 9. In this episode, we are going to discuss intermolecular forces. Remember, there are a lot of molecules in the reaction vessel. 6.022 times 10 to the 23rd for every mole of reactant, or for every mole of the object of interest. These molecules interact with each other given by attraction or repulsion forces. Intermolecular forces are categorized in 6 different categories. From top to bottom, strongest to weakest, we have ion dipole, hydrogen bonds, dipole-dipole, ion-induced dipole, dipole-induced dipole, and London dispersion forces. Ion dipole intermolecular forces are characterized by a charged ion interacting with a partial charge on a molecule. For example, in dissolution of sodium chloride in water, a sodium positively charged ion will interact with the partial negative charge oxygen on the water. The energy for this ranges between 40 to 600 kilojoules per mole. Hydrogen bonds are characterized by the force between a polar bond to an H dipole charge. For example, we have in the green an ammonia ion bonding with the hydrogen on the solvent, water. In a hydrogen bond, the participants of the polar bonds are either nitrogen, oxygen, or fluorine. The energy associated with the hydrogen bond ranges between 10 to 40 kilojoules per mole. Dipole-dipole interactions are characterized by interactions between two molecules with dipole moments. For example, hydrogen fluoride and hydrogen fluoride will interact with each other given by the fluorine on the left, the partial negative charge interacting with the hydrogen on the right with the partial positive charge. The energy associated with a dipole-dipole interaction is between 5 to 25 kilojoules per mole. Ion-induced dipoles are characterized by an ion charge interacting with the polarizable electron cloud. For example, the iron 2 plus ion is interacting with the diatomic oxygen molecule. The positive charge on the iron is pulling the electrons from the oxygen towards it, therefore generating a dipole that otherwise would normally not happen. The energy associated with this interaction is between 3 to 15 kilojoules per mole. Dipole-induced dipole is characterized by a dipole charge interacting with a molecule with a polarizable electron cloud. For example, the hydrogen chloride, the partial negative charge on the chlorine interacts with the diatomic chlorine and pulls electrons towards it, therefore inducing a dipole. The energy associated with this ranges from 2 to 10 kilojoules per mole. The last type of force that we'll talk about are London/dispersion forces. These are characterized by interaction of molecules that both have polarizable electron clouds. For example, chlorine gas interacting with another molecule of chlorine gas generates a dispersion force. The energy associated with this force is between 0.05 to 40 kilojoules per mole. This has been another episode of Beyond the Bonds Please like, subscribe, and comment with your feedback. Thank you so much.